Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is sum root to leaf numbers. This is another binary tree challenge. Rating is medium. So you are given the root of a binary tree. We're looking at an example of this. Containing digits from 0 to 9 only. Okay? Each root to leaf path in the tree represents a number. Maybe we should look at that. What that means is if you had a tree like example 2, look at the root to leaf paths. You've got 4, 9, 5, you've got 4, 9, 1, and you've got 40. Right, so those are the 3 root to leaf numbers in that tree. Okay, return the total sum of all root to leaf numbers test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. Okay, again, this is a depth-first search. I feel like it's on the easy side of medium. It's really not the kind of problem that lends itself to defining a stack and then pushing and popping things off a stack, but it is a problem that lends itself to a recursive solution, in which case we're using the recursive stack. We're using the recursive stack. So let's take a look at this, how it's going to work. We have this sum numbers and it takes a root. We're going to have to write a second function. That'll be a recursive function. And into that function, we're going to pass a root and a sum. So if we take this example 2, the first call to the recursive function, we're going to pass the root node of the tree, which is this 4 node, and the sum, which so far is 0. And every time we go into the recursive function, we'll multiply the sum times 10. Now 10 times 0 is 0, and then add the value of the node, which is 4. Okay? And then we do recursive calls for each child node. So let's start over here. We'll go from 4 to 9. And what we're going to pass into the function is the 9 node and the sum so far, which is 4. Multiply 4 times 10 is 40 plus 9. So from here to here, we've got a number of 49. Now the 9 node, again, we're going to need 2 recursive subcalls. Let's do the 5 first. What we're going to pass in there is the 5 node and the sum, 49. Multiply 49 times 10, it's 490 plus 5, 495. 5 is a leaf node. So we're done. We've got a number, 495. We can add it to the sum. And similarly with the other numbers in the tree. So let's look at an implementation. Okay. Int sum numbers. We will return the result of a recursive function. We'll call it DFS for depth first search. We'll pass in the root. We'll pass in the current sum, which is 0. All right. Private. This will return an int. DFS, we're going to pass in a tree node, let's call it node, and we're going to pass in an int, let's call it sum. Okay, let me pull this down and see, we can't get any more space yet. Okay, we'll deal with that. Okay. Let me check one thing here. The number of nodes in the tree is 1 to 1,000, but yeah, well, once we get down to well, some of these nodes, like the leaf nodes, don't. The leaf nodes do have null pointers for subtrees, so we've got to check that. So if the node equals null, that is, we're trying to call the function with the child node of a leaf node. Return 0. All right, update the sum. So the sum is going to be sum times 10 plus node dot val. Okay. Now, is this a leaf node? You got to check that. If node dot left equals null and node dot right equals null, then we'll return the sum. Okay. And finally, if it's not a leaf node, what we're going to return is the DFS of the left subtree plus the DFS of the right subtree. Let me move this over a little bit so we can see it. Sum. I think that's all we need to do. I mean, this is, recursion is maybe not the most intuitive thing, but it's probably most obvious. Let me think how I want to say this. Yeah, so a quick run through of how this is going to work. We're going to call the DFS the first time. We're going to call it with the for node and the sum of 0. Is it null? No. Okay, so we get the sum. The sum is 4. Are we at a leaf node? No. So we're going to return the DFS of the left subtree and the right subtree. The right subtree is just going to return 40. The DFS on the left subtree is going to need to do 2 more recursive calls from the 9, but it is going to return 495 plus 491, and then we are going to add 40, and we should get what we're looking for. So let's try and run this. Okay, accepted. And submit. What did we get? Oh, we beat everybody. Look at that. These are very small numbers out here, but I can't imagine what people are doing to to push the runtime out that far. Okay, that's a good solution. I mean, again, depth first search. Depth first search is very useful in trees. It's implemented with stacks. You don't always have to define the stack if you can see an obvious recursive solution. Then the recursion will function as a stack for you. And that's it. I hope you enjoyed it. learned something, maybe feel free to like, subscribe, comment, and we'll see you next time.